In this tutorial, we will be learning about intermolecular forces. Till now, the types of bond and types of forces we have learned are all intramolecular forces and intramolecular bonds. That is, between the atoms of an individual molecule. That is, in between Na and Cl in NaCl compound, in between H and O in water, and so on. But now on, what we'll be learning is that how a single molecule of water interacts with other molecule of water to form a group of water. How a NaCl molecule interacts with other NaCl molecules to form a group of NaCl molecules, and so on. That is intermolecular forces. Now, there are basically four types of forces, intermolecular forces you need to learn. They are: one, hydrogen bond; two, permanent dipole; permanent dipole; third one is permanent dipole and induced dipole, and the last one is instantaneous dipole and induced dipole. Now, these are the four types of intermolecular forces that we are entitled to learn in this chapter. So now, let's begin with hydrogen bond. Hydrogen bond, which the name suggests, it must have something to do with hydrogen. So, hydrogen bond is a type of intermolecular force or intermolecular bond in which a hydrogen atom must be attached to a fluorine, oxygen, fluorine, oxygen, nitrogen atom. That is hydrogen bond. A hydrogen bond can only occur when a hydrogen atom is attached to a fluorine or oxygen or nitrogen atom. Now, this alone is not enough for the formation of hydrogen bond. So, according to what I've written above, it suggests that a hydrogen must be attached to fluorine, oxygen, nitrogen. So, I'll write oxygen here and let other group over here be X. So, now this hydrogen is able to form hydrogen bond, but with whom will it form a hydrogen bond? So this is just the half part. This is just 1 hour. Now, for the formation of hydrogen bond, this is one case that must be fulfilled. Now, the other case is that the other case is O, N, and F group must be present in the other molecule, must be present in the other molecule. So if you are not clear, I will clarify you using examples next, but let's focus on this definition again. So for the formation of hydrogen bond, a hydrogen atom must be present over there because as the name suggests, it is hydrogen bond, so hydrogen must be present. So the hydrogen atom must be present and it must be attached to a fluorine, oxygen, or nitrogen atom. That is, it must form covalent bond with the fluorine, oxygen, or nitrogen. Next up. Now, this alone is not enough for the formation of hydrogen bond. So in the next molecule, fluorine, or oxygen atom must be present so that the oxygen from this atom, the hydrogen from this hydrogen can form bond with either one of oxygen or nitrogen or fluorine in the next atom, so that hydrogen bond is formed between them. So let's look into the examples of hydrogen bonds. Hydrogen bond is also mentioned as bond in short form. So now there are two things you need to know. Any compound which forms hydrogen bond with water dissolves in water. As bond with water, it dissolves in water. So this case means that a water molecule must be able to form a hydrogen bond with next water molecule. So let's look into the formation of hydrogen bond in water molecule, and let's look if the previously mentioned conditions are fulfilled or not. So we know that water is in this form with oxygen having two lone pairs. Now for the first condition, we add a hydrogen atom that must be attached to F or O or N molecule. So the first condition is fulfilled because a hydrogen molecule has formed bond with oxygen molecule. Now for the next water molecule, same is the case for the next water molecule, and for the next case I have told you that either of F or O or N must be present, So in the next molecule it is present. So now a water molecule can form the water hydrogen bond with the next water molecule. Hence now let's try to label or show how hydrogen bond is shown. So to show hydrogen bond, we must first draw the structure of the of the molecule. And now we must show the electronegativity difference. The oxygen has slightly negative, since oxygen is negative, electronegative, so oxygen has delta minus polarity, and two hydrogen atoms have delta plus. Same is the case in the below oxygen and below hydrogen. Now I have told you that hydrogen forms hydrogen bond with either of O, N or F. So hydrogen bond is formed in this case. The above hydrogen forms bond with this oxygen. So we must show hydrogen bond using dotted lines. Now why is the case? We can see here that oxygen has two lone pairs, both oxygen has two lone pairs. So and hydrogen has a delta plus polarity, which means it has zero electron at some instant. Hence this oxygen donates its electron to hydrogen and it forms hydrogen bond. So we must show hydrogen bond in this way. So one more water molecule over here with oxygen and two lone pairs, delta minus and delta plus. And the next water molecule can be present anywhere. It can be present here. It can be present over here too. Now, since oxygen has two lone pairs, so one oxygen can form hydrogen bond with two hydrogens. So you can make the dotted lines between any one oxygen and hydrogen, because we don't know actually between which oxygen and hydrogen occurs. So let me show a general notation of hydrogen bonding. So this may occur, and this may occur. This oxygen may form hydrogen bond with this oxygen may form hydrogen bond with this. So in this way hydrogen bond occurs. Now the water molecule below here, this oxygen forms hydrogen bond with this hydrogen, and so on. In this way there is a chain of hydrogen bonds. That is group interaction of water molecule is known as hydrogen bonding. In this way, a water forms hydrogen bond with each other. So now let's look into the next example, that is of ammonia. We know that ammonia is denoted in this form NH3, and since nitrogen has two lone pair, it is electronegative, so it has delta minus charge polarity, that is not charge, that is polarity, and hydrogen has delta plus 3 delta or 3 hydrogen. And next ammonia molecule is present over here. Now this symbol is known as delta, that is partial charge, that is at some extent it has negative polarity. It means this, it is not the actual charge, it is just polarity. That is, it shows the electronegativity difference between nitrogen and hydrogen, that is delta. So how do we label hydrogen bond over here? In this case, this nitrogen may form hydrogen bond with this, and the nitrogen over here may form hydrogen bond with this, and nitrogen over here may form hydrogen bond with this, and so on. So if you are asked in exam to label hydrogen bond, then there are many three things you need to concentrate. The first one is to show the lone pair electron in oxygen, nitrogen, and fluorine, because since they have lone pair and since they have high electronegativity, they can form hydrogen bond. So first thing is you must show the lone pair, and second thing you must show the polarity, that is delta minus and delta plus, and the last thing you must show the hydrogen bond using dotted lines. So now try to show the hydrogen bonding between ethanol and water. This is a simple assessment for you. So the next type of intermolecular force now we are about to study is permanent dipole. Permanent dipole. Now, just now I have told you that the delta minus delta plus means the polarity, that is, it shows the electronegativity difference between two molecules in two atoms in a molecule. So that means dipole. That is, dipole means two poles. That is delta plus and delta minus. If a molecule contains delta plus and delta minus, then it is said to be have dipole because it has two poles of delta plus pole and delta minus pole. So now, what does dipole, permanent dipole and permanent dipole mean? It means that any molecule which has a permanent dipole. So for the purpose of permanent dipole, you must have a bond between electronegative atom and a electropositive atom. So if we have electronegative atom and electropositive atom bonding with each other, it means that they have a electronegativity difference because it has delta minus polarity and delta minus polarity and it has delta plus polarity. So if the one atom is electronegative and the other is electropositive, then they are said to have permanent dipole interaction. Let's look at the example. The basic example is that of aldehyde and ketone. Now, suppose we consider a compound of this form. Now, We know that oxygen has high electronegativity, so it has delta minus polarity and it has delta plus polarity. Hence, this occurs in every instant. So this is called permanent dipole interaction. So with the help of permanent dipole interaction between this molecule and the same molecule over there, I have just turned it upside down. It's just like the mirror image. So the interaction between these two molecules is permanent dipole. Hence, in this way, a molecule of this compound is called ethanol. So ethanol bond with each other using permanent dipole interaction. So this is just the simple thing you need to know. You don't need to be completely focused on this matter. The important type of interactive force you need to know in this chapter is hydrogen bond. All the others, you just need to know the concept about them. You don't need to read detail about them. So next we'll be learning about permanent dipole and induced dipole. Permanent dipole means the compound which has dipole permanently. We have seen the example just now in the previous case. But what about induced dipole? Induced means formed due to the consequence of something. So permanent dipole and induced dipole means this. I'll make a general diagram. Suppose this is a molecule. It has electron and proton in equal amount, and this is the next compound. So in case of permanent dipole, we know that electrons and protons are separated partially. So this one is the dipole formation, that is this pole is delta plus and this pole is delta minus. So due to this molecule, it repels proton from this side to the other side. So proton are repelling this side and electrons are repelled from this side to this side. So electrons are present over the right hand side and the protons are attracted. So due to this permanent dipole, a dipole is induced over here. Dipole is induced here. That is, the negative has caused this electron has caused the electron repulsion, and the electron are repelled from this side and electron move towards the right hand side, and the protons are attracted towards this electron, so they move towards the left hand side. Hence, due to this permanent dipole is induced over here. So this interaction is called permanent dipole and induced dipole. And now due to the interaction between this electron and this proton, they form intermolecular force. Now, this is the only thing we need to know. We don't need to go in detail about this type or the type of intermolecular forces. Now, let's directly jump into the last type of intermolecular forces, that is instantaneous dipole and induced dipole. Now, suppose let's consider a molecule of methane. Now, carbon and hydrogen have same electronegativity, that is, they don't have much difference, so they are not polar, so they don't have dipole. And now, due to the lack of dipole, they are not able to form permanent dipole interaction, and permanent dipole induced dipole interaction. So, how does the molecule of methane interact with the next molecule of methane? So now in this case I'll label this methane in this way and this methane in this way. Suppose at any instant we know that electron does not stay in its particular position. It always revolves and it always moves. So at a particular instant, all of the electrons may be directed in this way and all of the protons are concentrated in this side. So at an instant, hence it is called instantaneous dipole. At certain instant, it may occur. So due to this instantaneous dipole is induced over here. How is it induced? It is induced in the same way as it was induced in the previous case. So this electron repels electron from the side and protons are attracted. So protons are concentrated in this side and electrons are concentrated in this side. So now this electron and proton form bonds and this bond is called intermolecular force. We'll start with intermolecular force, that is instantaneous dipole and induced dipole force. So these are the four types of intermolecular forces you need to learn in this chapter: hydrogen bond, permanent dipole, induced dipole, and the last one, instantaneous dipole, induced dipole. So I'll meet you all in the next tutorial.